Hello everybody, this is Mrs. Pagan. In today's lesson we're going to be talking about functions and their graphs, so let's go ahead and get started. Alright, I'm going to kind of go to the center of our notes really quick, and I'm going to look at this idea of what is function notation. Okay, so basically it's a notation we use to represent functions. So if I say function, f, you can write this as function notation, and it looks like this. Let's see. It is f of x equals, and let's use a line, mx plus b. It's a general formula for a line. So I'm going to actually write the way I said it. F of x equals m times x plus b. Alright, so that's how you would read it. The most important part is this f of x part, okay? And I want to tell you that since it is a notation, we tend to just not touch it so much, as you're about to see in some of the examples we'll go over. Alright, let's change our color really quick. It says evaluate the function for the given x. We are now looking at example 1. And what you are seeing is the function. So f of x equals 3x minus 1 is the function. Please practice that with me. F of x, f of x, f of x. Alright, and then it says the given x value, and x is 2. So we're going to go ahead and place x with 2 equals 3 times 2 minus 1. Notice that I use parentheses every time I put in the value. Now we are not going to touch f of 2. Remember, that's just a notation. So we're going to leave it alone. It actually means the same thing as y equals. And then we have 3 times 2 is 6 minus 1. So f of 2, don't touch it, equals 5. Now what this means is the following. This actually means that x equals 2, which is no surprise because they told us in the beginning, but it means that y equals 5. Ultimately, that's what that translates to. So f of 2 is the same as y. It's kind of cool. Alright, let's look at the next one. Now we have h of x. So we're going to go ahead and write the function. Ooh, fractions. Okay. Then we have the given x is 6, so we're going to replace that with 6. Now I like to change this to a fraction too, since 2/3 is a fraction. And what happens is we get h of 6 equals 2 times 6 is 12 over 3 times 1 is 3 plus 3/5. And then we have h of 6 equals 4 plus 3/5. So we can actually say that is 4 and 3/5 if we want to leave it as a mixed fraction really quick. Alright, well done. Okay, let's go into the bottom ones. There's only 4 problems in the bottom. I'm actually going to do the first 2 with you, and I'm going to ask you to try C and D, and we're going to go over that in class. So we are close to being done. Alright, in example number 2 it says decide whether the function is linear. So I'm actually going to help you understand what that means. And basically, if I look at all these, I can just kind of say, oh, not linear, oh, linear, oh, not linear, oh, linear, just by looking at the function. Because ultimately, if it has the characteristics of a line, which I'm thinking y equals mx plus b, or has a slope, or has only an x with a degree of 1, then it's good to go. Now, I can tell you that the first one is not linear because of the x squared. No lines that we have studied ever had an x squared, so the power of 2, therefore we can just eliminate that out of there. Alright, let's look at B. This one is linear, and I could tell you why. Because x has a power of 1. And also, it's in mx plus b form, which we know is a line. So a couple of things that you can definitely look for. For letter C, it has absolute values. Well, we know that absolute values are V-shaped, so this is not linear. Okay, and we also know that this one is not linear. Once again, because of x squared. All right. This one is because of, what was it again? Say it with me. Yes, absolute value. You got it. Well done. All right. Let's so that's how you can tell if something is linear or not. This one was the only one that was linear. Once again, because it has the form, the things that we need in a line. All right. Let's look at, it says, then evaluate the function when x equals -2. All right, so we're going to go ahead and I will do A and B with you and kind of let you go. We're going to go ahead and place x with -2. Notice that every time I put -2, I'm putting parentheses, especially if they're not there to begin with. Notice, -2, parentheses, -2 is again in parentheses, and same here. So please have that on your paper as well. It's very important. Notice I do not touch the function notation. -2 squared is -2 times -2, which is +4, plus 4 times -2 is -8, minus 1. And then we're going to go ahead, we're using the order of operations just to kind of simplify. We have 4 minus 8 is -4, minus 1 is -5, and we are done. Now, I like to sometimes just for myself write x equals -2, and in this case, y equals -5, just so that I can show that I can simplify and separate the x's and the y's from my function notation. But what I'm circling is the final answer. All right. Let's look at g of x. So we have g of x equals -3x plus 4. But once again, what we're looking for is when x equals -2, what happens? So we have g of -2 equals -3 times -2 plus 4. Okay? And we have g of -2 equals -3 times -2 is 6 plus 4. And g of -2 equals 10. This is our final answer. All right, I want you to go ahead and give C and D a try. These are the numbers that we are going to go over first thing as soon as you come. Make sure you try it, please, because you are getting experience without me. All right, have a great day. Can't wait to see you tomorrow.